So, hello everybody and welcome to this evening's webinar. Thank you very much for joining us. Welcome back to those of you who saw last week, and thank you for coming back again for part two. For those of you who haven't joined us before, I'm Katie. I'm one of the equine nutritionists here at Dengie, and we also have Dr. Katie Williams here behind the scenes, who is Dengie's technical and product development manager. We're really pleased to be joined once again tonight by Professor Jacqui Matthews, who is going to be talking to us about what we can do to promote sustainable worm control for our horses and why this is so important. So before we get started, I'll just quickly run through the plan and some admin for the evening. So as always, this webinar is being recorded and it should be available on our Dengie YouTube channel in the next week or so. We do have lots of other recordings on there from previous webinars, and also the part one webinar from last week's session is now available on there in case you missed it. To help with the quality of the recordings, we have therefore got the audience cameras and the microphones switched off. If you have any questions, please do pop them in the Q&A box as we go rather than in the chat box. Between us, we should be able to answer some questions behind the scenes, but we should also have some time for the questions at the end of the session as well. At the end of the session, we will send over a link to some multiple choice quiz questions, which everyone is welcome to complete to test yourself on what you learnt tonight. But for those of you who are AMTRA SQPs, BHS accredited professionals, or Pony Club registered coaches and assessors, you will need to complete these questions in order to be eligible for your points. But we'll explain a bit more about this at the end of the session. So that leads me on to introduce our guest for this evening. So for those of you who missed last week's session, this is Professor Jacqui Matthews. I think she's just popped up on your screens now. There she is. And on the screen, we've just got some of Jacqui's very impressive credentials. She firstly qualified as a veterinary surgeon before completing her PhD in parasitology at the University of Glasgow. Over the next 25 years in academia, she conducted numerous research projects looking at sheep, cattle, and horseworms, and at the same time she was also teaching at 3 of the UK's vet schools. Jacqui's research has generated more than 150 published papers. She's also authored lots of articles, given seminars, and was also the parasitology expert on the UK Veterinary Products Committee for a number of years. She's also a member of several subgroups of the Canter Initiative, which stands for Controlling Antiparasitic Resistance in Equines Responsibly. I think she's going to talk a little bit more about this evening. Jacqui now works for Austin Davis Biologics, where she's the Director of Veterinary Science, and she leads the research and development programme there, supporting the use of innovative diagnostics for evidence-based worm control for supporting equine health. So we're really, really delighted to have Jacqui back with us again this evening. So thank you very much, Jacqui. I will hand over to you if that's okay.
Thanks, Katie. Delighted to be back. Yep. It's been a quick week. I suppose it's only 6 days, and it's so much lighter tonight because the clock went forward in between. So it's nice not to be sitting in the dark hole that's our front room, given this webinar tonight. So welcome back to everybody that came last week. Thank you for coming and your continued support of the webinars, and also welcome to any new people. And as Katie said, you can access last week's webinar on the Dengie YouTube channel. So sorry, I'm just trying to share my slideshow. There we go. So you can, there'll be a couple of references back to last week's webinar, but don't worry, I'll hopefully make it very clear. And if not, you can watch last week's episode on catch up. So tonight's webinar will be covering the reasons why we need to apply sustainable worm control in horses and those principles that are underpinning these types of control approaches. I'll then focus on risk assessments as part of the approach to sustainable control, and then I'll focus on both non-chemical approaches and testing to support this holistic method of controlling equine parasites. And then at the end, I'll bring it all together and provide sort of suggestions on how you can integrate risk management, improved management, testing and treatments all together in a worm control programme. So just following on from last Thursday, we asked the question, why do we need to apply sustainable worm control in horses? Why don't we just treat horses with wormers all the time and suppress infections in that way? And what we know is now that helminth populations within groups of horses can be extremely large. There can be millions of worms present in individual populations. And we also know that the genes within the worms or helminths can be very variable. And that means when you apply a strong selection pressure to a large population where there's genetic variability, you can select for individuals that will be able to survive in the presence of that selection pressure. And in this case, it's treatment. So this little, it's very simple cartoon just gives you an idea of what goes on in worm populations when we treat horses with wormers. So even when the wormers are first introduced, it's likely that there might be a couple of worms within that population that are less sensitive to the wormers that have been developed to kill them. And those worms might contain DNA differences that change the target molecule for the anthelmintic or wormer and therefore be able to survive in its presence. And if we continue with treatments over time with the same anthelmintic, particularly if we treat all horses within a group, what we find is we start to select for these worms that have the sort of resistance conferring genes and reduce the number of sensitive worms in the population. And you can imagine as time goes on, the resistance worms will have more opportunity to mate with other resistant worms, and then you end up with a population of worms against which the wormers don't work. And that's exactly what's happened in the common equine parasites with respect to the 5 anthelmintic products we have registered for their use in the UK. So on the left-hand side of this table are the anthelmintic compounds that are available for using in horses. The 4 top compounds are for for nematode treatments, roundworm treatments, and the bottom chemical praziquantel as a specific compound that we use for the treatment of tapeworms. But it's also worth keeping in mind that you can use pyrantel salts at the double dose to treat for tapeworms. And if we focus on small redworms or cyathostomes and ascarids, we can see that there's a real issue with wormer resistance with benzimidazole or fenbendazole and pyrantel resistance really common in small redworms, with resistance to both macrocyclic lactones, ivermectin and moxidectin emerging. On the flip side, if you look at ascarid worms, which are important worms of foals, we find that macrocyclic lactone resistance is really common, both including ivermectin and moxidectin resistance in ascarid populations in foals, and including in the UK, with reports of resistance emerging to the other 2 compounds, fenbendazole and pyrantel. So there's a real issue, particularly with these 2 types of worms, which can be pathogenic and cause disease and death in horses, where there is a possibility of even multi-class resistance occurring within single populations of worms. Concerningly, in recent years, it's been the emergence of resistance in Anacephala perfoliata, the common equine tapeworm, to both praziquantel and to double dose of pyrantel. And this has been reported in the last 2 years on stud farms in the United States, which is also supported by anecdotal reports of concerns of resistance in populations of horses that develop tapeworm disease, but which have been recently treated with anti-tapeworm products. So not only do we have issues with resistance in small redworms and ascarids, but it's now seen to be an emerging problem in tapeworm as well. Not on this table are pinworms, and it would appear that where it's been tested, macrocyclic lactone resistance is also quite common in pinworm populations too. Strongylis vulgaris is a bit different. It's the large red worm, and it was pretty much eradicated by the introduction of macrocyclic lactones, which were very effective against the larval stages, the long-lived larval stages of Strongylis vulgaris. And what we found is this worm has been suppressed to a very high extent in worm populations in horses across the world. And what's clear is if we reduce the use of anthelmintics, this parasite seems to emerge because it does stay there at low levels. So it's an important parasite to keep an eye on as we move forward to worm control programs that reduce the usage of anthelmintics. As far as we're aware, there are no reports of resistance in this species of worm. So it's important to get the balance right when we're considering worm control in horses. And that means what we have to do is make sure that we avoid clinical signs developing in horses with larger worm burdens and make sure that they are managed properly, including the appropriate treatments for those burdens. But at the same time, we have to reduce selection for resistance so that we don't get to the situation where the worms are resistant in those horses that really need worming with high burdens. So it's really important to get that balance. So we need to consider that worming all horses selects for resistance, worming frequently selects for resistance, and underdosing selects for resistance. So going forward, we need to consider strategies where we don't worm all horses within a population, where we don't worm too frequently and we use a targeted approach, and where we make sure that horses are getting the right dose and the right wormer in all situations. And that will hopefully tip the balance in our favour in terms of prolonging the efficacy of the compounds that we have available. Now, this is a little schematic that I used last week just to try and explain the sort of what we do in terms of targeted programs for equine worm control. So what we do know is that in most populations of horses, the worms exhibit a negative binomial distribution. And this means, by and large, that 80% of the burden is usually just present in 20% of the horses. And that means if we use a testing approach, we can then identify those horses with the higher burdens and treat them appropriately. But more importantly, we can identify those horses with either no or low burdens, which do not require treatment. And at any point of time, if we apply that test, what we can do is identify in this case, horses are perhaps shedding lots of eggs. We can identify the high egg shedders and treat them with a wormer to kill. In this case, it would be small red worm, to kill the worms in that horse to reduce contamination onto the paddock. But at the same time, identify those horses with low burdens, which do not require worming because they don't have a pathogenic load of parasites. And by keeping those worms in these untreated horses not exposed to wormer, they will excrete parasites onto pasture, which won't have been through the selective process of worming, and with the anticipation that these worms will mix with the more resistant worms on paddocks. And when consumed and these worms mate at the next stage of the life cycle, these more susceptible worms, their genes will act to dilute the more resistant genes which have been selected by the treatment. And that's exactly how targeted treatments work. So we can base that on egg shedding within populations, but we also now have tests that will detect the level of burden within individual horses. So we can use these tests, which are based on antibody, to identify those horses with a higher worm burden and target them for an appropriate treatment, whilst leaving those horses with either no or low burdens untreated to reduce selection pressure or resistance. So I'm now going to go on to the principles that underpin evidence-based worm control in horses, now that I've discussed and explained how resistance occurs and how we should be avoiding it. So the most important thing we have to consider going forward in worm control programs in horses is to apply management approaches which will reduce the infection load in the environment. Because if we reduce that infection load in the environment, the horses that are grazing those paddocks are less likely to pick up significant burdens, and therefore when we test them, will test negative and therefore will not require treatments. So what we do in that case is we reduce environmental pressure, we test the horses and use those diagnostic tests to support the treatment decisions. It's important to keep in mind, though, that there are a couple of situations where we don't have tests that give us the full story about what's going on in an individual horse. And these are what we call high-risk situations. And such high-risk situations would be, for example, young horses with large larval burdens of small red worm. And in these cases, we would still consider giving a strategic treatment to target these larval stages of small red worms in the late autumn and winter. That would be an annual larvicidal treatment in late autumn and winter for small red worm. The other situation which we commonly encounter in practice is in groups of foals that are grazing paddocks that are contaminated with ascarid eggs. And the ascarid parasite has a long pre-patent period, so it takes at least 8 to 10 weeks between ingestion of the egg and the excretion of eggs in the foal's feces. So we can't use egg-based testing to identify those foals that might have higher burdens of larval parasites. And that's important because the ascarid larvae migrate through the liver and the lungs and cause damage there. So there are cases where we apply strategic treatments to foals early in their life to counter these early ascarid infections. Now, in order to support the diagnostic tools to use and their frequency, and to support what management approaches need to be applied or improved, we first of all have to do a risk assessment. And if we ask the appropriate questions, we can compile the answers and categorise horses as low risk, moderate risk, or high risk of worm infection. And each of these categories will then help provide us with the information upon which we can design the management approach, the testing approach, and where necessary, a strategic treatment approach. Now, you'll all remember this little cartoon from last week if you attended last week's webinar. And this is the fundamentals of a sort of sustainable control program in horses, and it brings together these aspects of infection risk, management, testing, treatment frequency, and anthelmintic resistance. So if you take the scenario, for example, where there is no pasture management, there's no dung removal and high stocking density, the infection pressure is likely to be high. And in that case, when you would go in and test that group of horses, more are likely to test positive, more anthelmintic treatments will be required, and that will provide a higher selection pressure for resistance. In the case where there's excellent pasture management, and that could be dung removal every day or two, adult horses with a low stocking density, the infection pressure is much more likely to be lower, with less horses likely to be infected and likely to have lower burdens. And in that case, when you go in and test those groups of horses, you'll find that a lower proportion of them will test positive, and therefore less anthelmintic treatments were required, and that will provide a lower selection pressure or risk for resistance. Now, all of our current guidelines, the BIVA Protect Me 2 guidelines that came out last year, and the Canter for Horses guidelines that came out last autumn, all advise that we should start our worm control advice with a risk assessment. And as I mentioned in the previous slide, once we've got an idea of the level of risk of a worm infection in a horse, then we can consider what we need to do to ensure that the management is ideal for reducing selection, for reducing the number of worms on pasture, and that will also enable us to work out what tests to apply and how frequently to apply them. And in the case of where we've identified a high-risk situation, there are certain circumstances where we would need to apply strategic treatments. Now, that might all sound quite complicated, but I'm sure if we were in a room and I was to ask you which of these horses is more likely to be at high risk of worm infection and which is to be likely to be at low risk of worm infection, I'm sure you would all choose the group of horses on the left-hand side. So we've got youngsters here, which are less immune to worms, so more likely to have a higher burden and could be infected with ascarids and small red worm, and perhaps grazing paddocks where there's a higher stocking density and no dung removal. And then in the other situation, we have a racehorse in training, which rarely gets out onto paddocks because it spends most of its time stabled and then on the training grounds or at the racehorse, and that is much likely to be a lower risk. So you can see there are these extremes, and there's no way that we should treat that horse, the racehorse, in terms of worm control in the same way that we'd approach worm control on a stud farm. So the risk-based worm approach to worm control does provide an opportunity for the owner and the prescriber to have a discussion about that individual horse, and that really should be happening anyway before an anthelmintic is prescribed. There should be a conversation about the horse's own signalment, how it's managed, and information about any testing and test results that have been carried out on that horse. That information then can be put together to categorise that horse in terms of its risk, and that will then inform the approach going forward for that individual. You'll be glad to know that there's a lot of information on this, particularly in the Canter guidelines in Chapter 1, which I helped contribute to, and there's a risk table within those guidelines that provides the sort of parameters and information that should be obtained when developing a risk assessment for a horse in terms of its worm risk. Now, these are just summarised here. It's very straightforward. So the things that we should be considering are the horse's age. And obviously, horses, particularly those young under 5 years old, are much more susceptible to worms than adult horses are. And of course, in the foal group, then you've got the consideration of ascarid and small red worm infections. In terms of tapeworm, for example, horses of all ages can be infected with tapeworms, but there is some evidence from research studies that might indicate that younger animals are more susceptible, particularly to having higher burdens of tapeworm. Then we need to consider the grazing pattern of horses. Are they out all the time, or are they stabled most of the time, or does that change across the year, and at what stage of the year are we at in terms of that horse's grazing pattern? Then we need to consider paddock management. What's the stocking density like? Because obviously the more horses you put on a paddock, the more likely that paddock is to become infected with worms. And also, has the paddock been rested? Because the worm stages will die out over a certain amount of time, and we'll come back to that. And also, has the paddock been grazed with other species? Very important question is to ask about dung removal. And that is one of the best ways that you can reduce infection pressure in the environment where horses graze. So you would ask about dung removal. Is it full? Where's the dung placed? And how frequently is it removed? And then we can have to consider other risks to the horses that you are providing advice for. Is it an open and closed yard? Do new horses come in, and with the possibility of bringing in new infections or infections that are resistant to wormers? And also, in that case, linked to that is, if there is an open yard, what are the quarantine procedures and how effective are they? And then on top of all this sort of history taking about management and signalment of the individual horse, it's really important to look at its recent test results. For example, is a horse a consistently high shedder of eggs, or is it a consistently low shedder of eggs? And in terms of antibody test, is the horse repeatedly positive in a tapeworm or a small red worm blood test, or is it consistently low in those tests? And if these tests aren't being applied, then there's the opportunity to have the conversation with the owner or the manager of the horse about how they can apply these tests usefully to inform their worm control plan. Then once you have an idea of each of the answers to these parameters, you can use these to categorize that horse as low, moderate, or high. And then you can use that category to inform your advice on management, testing, and treatment. Now, this might also sound very complicated. So in order to help with that, at Austin Davis, we have developed a very simple risk calculator tool. And that asks key questions around these components of a risk assessment. And then once those 9 questions have been answered, they go into an algorithm, and then the output is a categorization of that horse in relation to its infection risk. And the good news is, as part of the tool, the actual output provides information for each of those categories. So, for example, if you were to take a low-risk horse based on your assessment or the answers to the questions in the calculator, what you need to do is say, well, that's great, well done to the client or the manager of the horse. You're doing a good job. It seems that your horse is at low risk of infection, particularly if you've included the results of diagnostic tests. But are there any remaining gaps in management that could make it even better and reduce infection pressure even more? So that would lead you to perhaps maybe optimize the frequency of dung removal, or where the dung is placed, or other management factors that you could provide advice on. That low risk category would then help optimize your frequency of testing. Are they tested too often? Are they tested too little? Or is it just right? And then always be aware in this situation not to be complacent. So any change in management, particularly if it's associated with changes in that horse's test results, going from negative to positive, must be considered. And it's important to reassess these horses 12 months later, and sooner if there's been a major change in management. For example, it's changed yards, or they've introduced a whole lot of new horses to the population. Similarly, you can take the same approach in terms of either when horses have been categorized as moderate or high risk, and then go through these steps and where improvements can be made. And obviously, the higher the risk, the more opportunity there is to make improvements in management. When there's a very high risk identified, try not to do too many management changes at once, or advise too many management changes at once, because that can become overwhelming for people and then they won't engage. So it's important in the high risk case to prioritize the things that could be done, and perhaps the simplest things like, okay, well, what about dung removal? Is that something that we could start doing if you can't change your stocking density, for example? Let's test more so we can get top of those high egg shedders sooner to reduce transmission into the environment. So these are the things you can advise. This is just what what's your worm risk calculator tool looks like. So you can either go to watchyourwormrisk.com, or you can scan this QR code and it takes you to this field of 9 very straightforward questions. And each question then you have to answer a specific parameter, and based on the specific parameter it's answered, then those results will go into an algorithm, and that will provide the output of the categorization of that horse in terms of its risk. And it's not just something you should take the advice from at face value, but it provides the key pointers of where you could go in the next steps of that horse's worm management plan. Okay, so that's risk assessment. So the first big step in sustainable control is to reduce infection risk by non-chemical approaches. And that won't only have the impact of reducing selection pressure for resistance, but it will also have the positive effect of reducing the amount of chemicals that are given to horses, and therefore the amount of chemicals that are going into the environment. Because some of the chemicals, for example, the macrocyclic lactones, are quite ecotoxic and then have detrimental effects on things like dung beetles. So it's a bit of a win-win situation. If we can drive down the amount of chemicals we use, we can reduce selection for resistance and reduce the environmental impact of these wormers. And there's a whole chapter in this that I've written in the Canter guidelines that goes through the various steps of non-chemical approaches to worm control, and I'm going to show you some of the evidence basis I provide in that chapter in the following slides. So first of all, dung removal, that's not rocket science, but it's a really straightforward thing to do. What we recommend, based on what we know about the epidemiology of the worms that we work with, is the more regular removal that you have, the better the chance you have of reducing contamination onto paddocks. And we recommend that dung is fully removed at least twice a week. And in so doing, what you'll do is you'll remove the eggs of the strongyles, the small red worms, for example, before they have a time to hatch and develop to L3, which migrate out and go onto the grass, and then horses eat them. So that takes at least 2 weeks in optimal conditions in the UK. So if you remove dung before those L3 develop, then you're going to reduce and break the life cycle and reduce contamination onto paddocks. If you lift the dung very frequently, then you reduce the opportunity for parascaris eggs getting washed onto the paddocks, and they stay in this state with the larvae developing in them to infect foals from throughout the season and from one year to the next. So the more frequently you remove the dung from foal paddocks, the better the chance you've got of reducing ascid contamination. And likewise, if you frequently remove dung from paddocks, then you're going to stop the encounter of arbuatid mites, which are the intermediate host for tapeworm eggs, with the tapeworm eggs. So they come into the dung pat, and they're very attracted to dung pats, particularly when they're fresh. So if you lift the dung pat frequently enough, you will reduce that interaction and therefore reduce the levels of infected arbuatid mites on paddocks. And it's really important to place dung heaps away from paddocks, because the worms can migrate back onto the paddocks as L3 or as cysticercoid tapeworms within arbuatid mites. So we recommend at least 12 feet away from paddocks, ideally more. And it's important to place these heaps away from water courses as well, particularly if they contain anthelmintics, which can then get runoff and rainwater into water courses and contaminate the environment. So this is just some of the evidence basis for dung removal. This was a really nice study done by Rupert Herd in Newmarket in the 1980s. He was actually on a sabbatical from the States. And what he did is he took groups of ponies on different paddocks. And in one paddock, he removed dung twice a week. And on the other paddocks, he didn't remove dung. But what he did is he treated these ponies with either oxybenzole, which is a benzimidazole, or with ivermectin. And what we see on these graphs is the amount of L3 that develop on these paddocks over the course of that season. And it's very clear here that you can see on those paddocks where there is dung removal, even although those ponies had the highest fecal egg counts of the 4 groups, there was a suppression of the larval increases that you generally expect from midsummer onwards. And then in the case of where you applied treatments but no dung removal, you can see that the L3 levels are increasing, even in the presence of a persistent anthelmintic such as ivermectin. So this was the first evidence that dung removal could have a significant impact on the level of IL3, small red worm L3 contamination that are on equine paddocks. And an advantage of the dung removal, he also observed, was that it increased the grazing area by 50%, since there wasn't that characteristic separation of pastures into roughs and lawns. So there was a better quality paddock for the horses to graze. This study was followed up by a couple of studies, some of which we were involved with, including where we removed dung twice weekly from paddocks at the donkey sanctuary and compared the fecal egg count results in donkeys grazing these paddocks with the fecal egg count results of donkeys which grazed paddocks where dung was not removed. And what we found that we both automated removal of dung or manual removal of dung on these paddocks demonstrated a significant suppressive effect on the downstream egg counts of those donkeys compared to those donkeys that grazed paddocks where dung was not removed. And either type of removal, automated or manual, corresponded to 20% compound monthly reductions in fecal egg count. I was actually surprised how quick that effect was for the time it takes the parasite to go through its life cycle in adults to develop. But fairly quickly, we were able to show a significant impact on fecal egg counts when we used dung removal compared to no dung removal. This other study that we performed in 8 leisure horse yards in the UK, in this case, we observed fecal egg counts in horses after treatment with Pramox, which contains moxidectin and praziquantel. And what we wanted to do was we wanted to compare 4 yards where dung was removed regularly with 4 yards where dung wasn't removed. And what we found that actually where there was no dung removal at the start of the study, the egg counts were higher compared to those horses where there was dung removal. And what we found was that the egg counts post-treatment started to come up quicker and at a higher level in those horses where no dung was removed compared to those horses on paddocks where dung was removed. So again, a very good indication that the regular removal of dung was associated both with both lower fecal egg counts, lower egg shedding post-treatment, and a lower prevalence of egg shedding in those treated horses. So these are 2 very good reasons to try and encourage more people to remove dung from paddocks. Now, the timing of dung removal is based on, well, some studies in abroad, but in the UK, a study that we did in Glasgow, where we actually took dung and we contaminated it with eggs and we placed it on paddocks that had never been grazed by horses before. And what we then did is we looked at the larvae that migrated onto the grass surrounding the dung after the placement of the eggs into the dung. And what we found is that a couple of larvae had hatched out and developed into 3rd stage larvae within the 1st week, but then that increased in the 2nd, 3rd and 4th weeks. So on the basis of this, we recommend that people should be removing dung at least once a week and ideally more than that. Now, if I just talk a little bit about stocking density, I mean, this is quite obvious. Obviously, the higher density that you graze a paddock, the higher the chance that you will have contamination with eggs of the different parasites. This study that was published a couple of years ago looked at some extremes. So it looked at horses grazed at very low stocking density, 0 to 2 per hectare, right up to groups of horses that were grazed at over 30 horses per hectare. And then they looked at their egg counts. And it's quite clear from this study that you can see those grazed at low stocking density have 0 egg counts. And as we increase the stocking density, the egg counts go up significantly. And you can see the level of significance, particularly compared to these high and extremely high groups, even with horses that are grazed at this medium density. So we always recommend that horses should be grazed as a low stocking density as possible. And we work in acres in the UK, so we would ideally have at least 1 acre per horse. Another approach you can take to reduce contamination of paddocks is to use management with species that don't cycle the common horse parasites. And in this case, this was a study done in the Netherlands a couple of years ago, where they actually took groups of ponies and they grazed them either on permanent equine paddocks, or they grazed a second group of ponies on paddocks which were pre-grazed by sheep, and then the ponies were moved onto those paddocks in the middle of the grazing season. And each year in this study, they necropsied the ponies at the end of the season, and they compared the parasite burdens between those that grazed permanent equine paddocks and those that had grazed paddocks pre-grazed by sheep. And even in this short time scale and in these very small groups of ponies, you can see the considerable difference between worm burdens, in this case small red worm or cyathostomins, between those ponies in group 1, that graze the permanent equine paddocks and those that graze the paddocks pre-grazed by sheep. You can see the difference in the total worm burdens, and particularly in the second 2 years, the massive difference in early L3. These are encysted larvae. Now, obviously, if we were to repeat this study and we were also to remove dung, you would substantially lower all the burdens in all the groups. So it's important to, when you're considering cross-grazing or rotational grazing with ruminants, is to remember that there are 2 parasites that can infect both ruminants and horses. One is called Trichostrongylus axii, which is a non-pathogenic stomach worm and isn't really a concern in horses. And the other is the trematode or liver fluke Fasciola hepatica. So it's important where you're considering and providing advice about grazing with ruminants is to do a risk assessment on whether or not those ruminants are likely or are infected with liver fluke, to test them accordingly, and in animals that are positive, make sure that the anthelmintics that are being used against liver fluke are working. It's also important to try and reduce the transmission of liver fluke in the environment by fencing off those areas where the intermediate snail lives, such as marshy areas and wet areas. I'm just now going to go on to reducing infection risk by testing. So we've already talked about risk assessment. We've talked about how we can drive down the transmission of parasites in horses by management measures. And now we're just going to look at how we can reduce anthelmintic use by applying tests in horse populations. And as you'll remember from earlier tonight and last week, worm infections in horses exhibit this negative binomial distribution. And that means that the majority of horses in a population, approximately 80%, tend to have a low or no worm burden. And then there's a small proportion of horses within that group that have a higher worm burden. It's important to remember that in young populations of horses under 5, these percentages can change a bit with higher levels of burdens in a higher proportion of horses, but that can be assessed by testing. Fecal egg count testing should be the cornerstone of all parasite control programs, because all horses have potential to carry worms and excrete eggs and contaminate pastures, but oftentimes only a few of those horses will significantly contaminate paddocks with eggs. Young horses, as I said, tend to have a higher worm burden and shed more eggs, and the fecal egg counts increase more rapidly after worming. So when we're considering groups with young horses, we have to think about the frequency of testing and increase that. It's important to remember that fecal egg counts are really just a measure of the eggs that are going onto paddocks, and they do not have a linear correlation between the levels of eggs that are being excreted and the level of worm burden of either nematodes or roundworms or cestodes or tapeworm burdens. There's no direct relationship. So they only really provide information about the amount of eggs that are going on to paddocks, and therefore are very useful tools for reducing transmission onto paddocks by reducing egg shedding, and also for testing the effectiveness of wormers. These are just some of the studies that we've done previously with egg count distributions in horses, and these just exemplify exactly what you would expect if you were to fecal egg count groups of horses. In this case, this was a number of leisure horse yards in the UK, where we found that the vast majority of horses shed eggs at below 200 eggs per gram threshold. About 80% of horses, even throughout the study, it was consistent, and only a small proportion of horses shed eggs higher than these. And what we found is, on different sampling occasions throughout this single season, we found that few horses changed category from no treatment to treatment category, and that was more likely to happen in younger animals. This is other data from breeding farms in the United Kingdom, and this just shows you a very nice negative binomial distribution of egg counts in over 1,200 horses from 22 farms, where you can see the egg per gram range on the x-axis and the percentage of horses on the y-axis, and it exemplifies the very high percentage of horses that shed eggs below 50 eggs per gram in this study. These were mostly mares, and what we found is that the majority of horses that shed over 200 eggs per gram in this study were under 4 years old and under. Now, it's important when we're applying fecal egg count tests in practice is to get the best value we can out of them. So we did some research around what factors might affect the variation or variability in fecal egg count analysis. And I am here, I provide some guidelines combined with some of the output from Martin Nielsen's work in the United States about how to optimize this type of testing. First of all, it's important to collect dung as fresh as possible within 12 hours of it being deposited. And obviously you have to identify the horse from which the dung has been excreted. And it's important to consider that worm eggs are not evenly distributed in dung. So if you picked up 3 different dung balls, for example, you might find that one would have, if you did an egg count on one dung ball, it could be 50 eggs per gram. And if you did an egg count in another dung ball from the same pile, it could be 500 eggs per gram. And if you took a third one, it could be 200 eggs per gram. So there's this very uneven distribution of eggs across the fecal pile. So in order to try and reduce that variation introduced by that over-dispersion of eggs, it's important to take a material from several areas of the dung pile. And we would advise at least 3 areas from the dung pile, and then give them a really good mix together and collect at least 5 grams. The more grams that you collect, the higher representation you'll get of the pile. But then obviously, if you collected more grams, it's really important, taking in further subsamples, is to mix those samples again. You can't do enough mixing in order to reduce the variation that's introduced by the distribution of eggs in dung. Then you place your collected dung into a labelled sealable bag or a box, making sure that there's no air. So you either squeeze the bag or you fill the box, because the air being present will contain oxygen, which will help promote egg hatching, and then you'll be able to measure those larvae in an egg count test. Keep the samples cool, because the warmer the samples are, the more likely the eggs are to hatch. And then if the sample isn't processed immediately at the laboratory, it should also be refrigerated. And all samples must be processed within 5 days of the initial collection. So in using fecal egg counts in practice and worm control programs is very straightforward. They're particularly useful to inform treatment decisions to reduce nematode or roundworm egg shedding onto paddocks, and should be applied from horses aged 6 months and older. In very young horses, around 6 months, they're really useful tools to identify whether or not horses are shedding ascarid or strongyle eggs or both, and that will help inform which anthelmintic to choose, because you know that these worms have different resistance profiles. We would recommend that you assess horses every 8 to 12 weeks in the grazing season for fecal egg counts. And in the many horses that are now kept out over the winter, we'd recommend that you also fecal egg count test those horses towards the end of the winter, just to detect what levels of shedding that they might have and whether or not they require a treatment. It's important to wait a minimum of 8 weeks after benzimidazole, parenteral or ivermectin treatment in order to allow the egg counts time to come back up after treatment, taking into account any persistent effect of ivermectin plus the pre-patent period, and 12 weeks after moxidectin treatment. What we find at the moment in the UK and in many countries overseas, that over 99% of the strongyle eggs that are present in fecal egg counts are small strongyles or cyathostomins. If there's a concern that there might be the presence of large red worm, particularly where there's been significantly reduced use of anthelmintics, especially macrocyclic lactones, the larvae can be cultured and identified to both large strongyles and small strongyles, because it's particularly important that we do detect any emergence of Strongylis vulgaris, because it's such a pathogenic worm. As I said earlier, fecal egg counts show poor correlation with adult worm burdens and do not provide any information on larval counts, and they have poor sensitivity for detecting tapeworm infection. What fecal egg count testing is very useful for is assessing the effectiveness of the wormers used, and we would recommend that everybody perform a fecal egg count reduction test annually, ideally in the summer when egg counts are likely to be higher, and then you're more likely to have a better chance of assessing whether or not that worm is working. And the fecal egg count reduction test is very straightforward. You test horses and treat those with an egg count of over 200 eggs per gram. And then you then egg count those horses after 2 weeks after treatment and assess the percentage reduction. There's a lot of information on both the use of fecal egg counts in horses written by Martin Nielsen and I in the Canter Guidelines, along with a chapter on testing for anthelmintic resistance, and also importantly, when you do detect anthelmintic resistance, how to report that lack of efficacy. Now, as I mentioned in the previous slide, fecal egg counts do not correlate with cyathostomin or small red worm burdens, because they don't take into account the variation in egg shedding by female worms. nor do they take into account the presence of mealworms, of course, or larval worms. And this is just an example of the types of burdens that we see in horses with small red worm and the related egg counts. This is a group of horses that we obtained the guts from an abattoir in the early 2000s when we were initially developing the small red worm test. And what we did is we looked at the total mucosal burdens as well as their total burdens of worms that we estimated based on subsampling the intestines. And then we also looked at their eggs per gram. And you can see here the level of worms. It does not relate to the egg count, egg shedding level of that horse. For example, in this horse 23, the eggs per gram that we estimated in its dung was 100, but that horse actually harboured 3.69 million worms in total, the vast majority of which were mucosal stage larvae. So this is why egg counts testing is not useful for telling us about the burden of worms within individual horses. Of small red worm. And the same can be applied for tapeworm, where it's been shown that tapeworm infections, if you look at abattoir surveys, for example, that a large proportion of tapeworms in horses can be immature and therefore do not release fertilized segments or proglottids. And also a high proportion of tapeworm infections can also be non-gravid tapeworms. So in these studies where they looked at 91 and 114 horses, they found that in the studies, only 16 to 17% of these horses actually, or 16 to 17% of the worms counted were actually gravid. So that just demonstrates the lack of sensitivity of fecal egg count analysis for tapeworm infections. And also summarized here in this table that we published a couple of years ago, where we looked at various fecal egg count methods published in different studies, and we reported the low sensitivity of detection of infection. And even with these sort of higher volume methods, where sometimes there is an increased sensitivity, particularly above 20 tapeworms, when the method was used in different populations of horses, it reported a low sensitivity. So for these reasons, antibody tests have been developed to help us understand the levels of worm burden within individual horses to help inform both clinical aspects, but also as well treatment decisions. And these are based on the fact that antibodies to specific worm molecules can be detected either in blood or saliva, and levels of worm molecule-specific antibodies have been shown to correlate with the level of worm burden. So if we purify these particular components of the worm and seek relationships between antibodies levels to these components and the level of worm burden, we can then develop that into a test. And the test that we use is the enzyme-linked immunosorbent assay, or ELISA method, and that allows us to quantify the amount of antibodies that stick to those specific worm components, and then we can provide a readout, which will then provide information on the level of burden of the tested horse, and the knowledge of that burden then informs the decision to treat or not. Now, probably the most familiar antibody test that you're aware of is the tapeworm antibody test. So there's blood and saliva tests for tapeworm. And it's important to be able to measure the amount of antibody to tapeworm to inform and burden, because unlike the cyathostomins, where relatively large burdens can sit, thousands of worms can sit in horses without any clinical signs, what we found that burdens in excess of only 20 tapeworms can cause quite severe intestinal damage. This study performed a couple of years ago took material from the abattoir, and they compared the damage to the equine enteric neuronal system, as well as a histopathological damage in horses grouped according to their burden. And even horses which had only 20 to 100 tapeworms were shown to have significant damage of extensive areas of mucosal ulceration at the ileocecal colloid junction, compared to horses with very low burdens or no burdens. And as I mentioned, of concern, not only do we need to consider treating horses so that they don't have large tapeworms worm burdens which can cause damage, but we also have to consider getting the balance right now, because there have been demonstrated treatment failures with anti-tapeworm products in the United States. So like with the situation with the roundworms, small red worms and ascarids, we now need to balance treatment requirements to treat horses to reduce the disease risk without overuse of wormers that increase resistance risk. And all the guidelines now say that testing should always be used to inform tapeworm treatment decisions in individual horses. So this is just a little bit about the tests that have been developed. So first of all, there was a blood test that initially developed in Liverpool, and then it's now been further developed and validated at Austin Davis and is available for vets at Austin Davis. And the blood sample is taken obviously by a veterinary surgeon who submits a sample. The antibodies measured as a serum score, and then these serum scores are then compared to different categories, and the horse is then classified as low, borderline, or moderate high in its diagnosis. And we recommend treatment for horses that fall within the borderline and the moderate high diagnosis. It's important to remember that antibodies take a little while to reduce after tapeworm treatment, so we don't recommend testing until 4 months after the last anti-tapeworm treatment. Over the last 10 years, the saliva test has been available. It basically follows the same principles of the blood test. It measures the same type of antibody to the same antigens that are released by tapeworm, but it's a special 3-format test that has to account for the properties of saliva, including its stickiness and flow rate. And the results of the saliva test are reported as saliva scores with the same categories as the serum test, and treatment is advised for horses with saliva scores within the borderline or moderate high categories. Antibodies do drop more rapidly in saliva, and we recommend that horses can be tested a minimum of 12 months after the last treatment. It's important to remember that the scores in both tests demonstrated strong positive correlations with tapeworm infection intensity in the validation study using gold standard samples from horses for which tapeworm burdens were enumerated. And in these studies, no horses with a potentially pathogenic tapeworm burden of over 20 worms were misdiagnosed at the 1+ burden cutoff. So that's a cutoff that is it covers both the borderline and the moderate high categories. And that's why we recommend treatment when horses report in both those categories. So when should we test for tapeworm? So studies have shown when you look at the types of worms that are present in horses that are necropsied, what we find is that horses build up immature burdens over the summer, and these start to gradually mature to become adult worms, but they don't really become gravid till later on. It's quite a relatively slow life cycle. And these gravid worms are present in the winter and are higher proportions in the spring. Now, as I said earlier, it's important to treat horses to reduce egg shedding. So in this case, you could test for horses for tapeworm in the spring, identify whether or not they've got a burden, and then therefore if you treat those horses in the spring with a burden, then if the treatment's successful, you reduce egg shedding onto the paddock. And that's important because this is the time of year when we know that irribated mite intermediate hosts are starting to increase on paddocks in the spring and in the summer, and therefore they'll be more likely to have an interaction with those eggs that are excreted. So it's important to test in the spring to reduce egg shedding, to reduce contamination onto paddocks, and have an impact on transmission via the irribated mite. Now, horses tend to accumulate tapeworm burdens, particularly over the summer grazing season when there are more infected mites about, such that higher burdens are more likely to occur at the end of the grazing season in the autumn. So we also recommend that horses be tested in autumn to identify those horses likely to have a higher burden and therefore at risk of colic, and treat positive horses to reduce that risk of disease. And these graphs just show you just an example of a yard where we identified a high prevalence of tapeworm in horses at the start of the study, and the owner of the yard was keen to reduce the number of horses that were reporting with a positive equisal saliva test. And you can see the positive test is a negative 0.9, so you can see how high the levels of infection were at the start of the study. So we went in with a more frequent testing and treatment regime, and over the course of the next year, we reduced significantly the saliva scores in this group of horses, and we also reduced the number of horses that were testing positive in the following year. It was important also to investigate the management that was ongoing at that yard to understand why there was such a high level of infection, and we recommended some management changes which helped reduce the transmission of tapeworm within the environment of these horses. This is just a graph to show you the reduction in antibody in saliva to tapeworm after treatment. And in this study, we examined horses that were not exposed to further infection, because obviously that would stimulate more antibody to go up. So it was important to look at horses that were either in very, very clean paddocks, or horses where they were not grazed, they were actually housed during the trial period. And then what we found that is all horses moved to a non-treatment category within 12 weeks. So that's why we recommend that horses can be tested after treatment from 12 weeks onwards. Now, the use of Equisal in horses has led to significant reductions in the application of anti-tapeworm wormers in the UK. And this is just a data set that we compared the Equisal results of horses that were positive and those that were negative from 2015 to 2023. And what we found is that a third of those horses, only a third of those horses were actually reported as positive, and over 2/3 of those horses reported a low saliva score. So that's when you look at the number of wormer tests here, that's well over 200,000. That's a significant reduction in the use of anti-tapeworm products, and hopefully reduce selection pressure for resistance. This is typical of what you would see. This is just an exemplar selection of yards from our database. And you can see that in this case, we're looking at the prevalence of infected horses as reported as in the Equisal test. And in the majority of yards indicated in blue, most yards have a low prevalence of infection below 20%. A few yards where the prevalence of infection in individual horses is between 20 and 50. And then we have just a couple of problem yards. And these are the sort of yards that we see, and we quite often go in and help provide advice with these yards on how to reduce tapeworm transmission through both management approaches and a more frequent testing and treatment approach to identify those high egg shedders within the populations. Now, I'm just going to touch very briefly on the small red worm blood test, because obviously that's a blood test. It's only available for vets to use in practice, but it's important to be aware of its existence and what it can and can't be used for. So as I mentioned earlier, fecal egg counts do not correlate at all with small red worm burdens, particularly encysted larval burdens. And in this case, this antibody test can be used instead to measure the level of antibody, which provides information on the level of small red worm burden up to 10,000 worm burden threshold. And based on the validation studies and field studies that we performed before the test was launched, we advise it as an aid to direct treatments in low infection risk settings to reduce anthelmintic use where all group larvicide, particularly larvicidal treatments, are being considered. Because for many years we didn't have a test that would tell us much about horse levels of infection with small red worm, whether it's larvals or adult stages, and we just used to recommend that all horses be treated every year with a larvicidal anthelmintic, particularly moxidectin. And because of the concern about resistance in moxidectin, what we now advise that either horses, if they're in a low risk category and unlikely to have a high burden of small red worm, then they don't be treated with this larvicidal therapy. If people are still concerned about whether there's risk factors they're not sure about, or whether they're really concerned about withholding this treatment, they can use a small red worm test to inform whether or not that horse has a burden that can require treatment or not. It can also be used in practice by vets as a need to support diagnosis of larval cyatostominosis, and also as a rule-out test, because it sensitively picks up low burdens of cyatostomins. It can be used as a rule-out test for these worms as a cause of various types of intestinal disease, such as diarrhea or colic. The small red worm blood test is a bit different from the tapeworm blood test in that we measure antibodies to some native antigens, native proteins released by the tapeworms. In this case, with the small red worm blood test, we measure antibody responses to cloned recombinant proteins from the 3 commonest cyathostomin species. And these proteins were shown to be expressed or detected in either mucosal early stage larvae and late and third stage larvae and developing L4. And also a second protein, which was shown to be expressed in the later developing larval stages and the luminal stages, which are L4, L5s and adult worms. So the antibody levels that we measure against these proteins provide us with information on the total burden of cyatostomins up to a burden threshold of 1,000. And so we report the serum scores from the test against 3 burden thresholds of 1,000 small red worms, 5,000 small red worms, and 1,000 small red worms. And then based on the serum score that that horse has and a risk assessment by the vet, then the decision can be made whether or not to treat it with anthelmintic. To support vets in practice in how to use the test, we've provided detailed guidelines on selection of horses for use in the test. And as I mentioned, because horses in a high infection risk situation are likely to have a burden way above 10,000 cyathostomes, and because they may be more at risk of disease, we would recommend that they don't be used in the test and they should receive a larvicidal treatment in the autumn. That would be like particularly young horses or where management is poor or the horse has repeated egg counts above 200 eggs per gram. This schematic just goes through the steps of making decisions and interpretation of the small red worm test. So just to consolidate what I just said, horses in a moderate or high risk category should still be considered for larvicidal treatment in the autumn and winter. And then we need to consider how to address management to reduce L3 transmission to reduce the risk. And then those horses identified as being a low risk of infection, you can either not administer an anthelmintic treatment, or you can use the small red worm blood test to inform the level of burden based on the serum score of that horse. And then the vet can then look at the serum score thresholds and decide whether or not the horse should be treated at a burden of either over 1,000, 5,000 or 10,000 worms. In the case of the burden of over 10,000 worms where there'd be a serum score above 30.46, we would recommend that they consider larvicidal treatment or consider anthelmintic treatment, and likewise assess management to reduce transmission of the worms. And then for serum scores below 30.46, i.e. burdens likely to be under 10,000 worms, then the vet with the owner will need to consider the risk level to select the worm burden threshold for treatment. Obviously, if they select a higher threshold in very low risk groups, they will treat less horses and reduce the risk of resistance, whereas in a more conservative approach where they would treat at the 1,000 burden threshold of 14.37, they would be treating more horses in that case. This just shows you the practical use of the small red worm blood test over many years in a small group of horses, which are adult horses on very clean paddocks from which dung is removed twice a day. And you can see that these horses never got anywhere near the 10,000 worm burden threshold as measured in this small red worm test, and therefore, together with low tapeworm scores, they have not received any anthelmintic treatments now for over 5 years. These are just other cohorts of horses that have been tested in the small red worm blood test. In this case, this is a group of 981 sport horses from a sport horse clinic in the EU. And these horses are obviously not grazed extensively and probably were exposed to anthelmintic treatments previously. But in this case, the use of the blood test has shown that over 60% of these horses have a very small burden of small red worm, less than 1,000 worms. That's a very small burden. And indeed, over 80% of them had a burden of less than 10,000. So using the results from these tests, there can be significant reductions in the use of anthelmintics in such horses. Now, the small red worm blood test is also useful for assessing the level of burden in horses which are considered at low risk, but actually using the test results, we can then investigate further what is going on. So in this case, these were flat race horses in the UK, and we tested them in the small red worm blood test, and we found that actually only 48% of them were below the 10,000 threshold. And we were quite surprised at this because we assumed they weren't grazed much. When we went back through the vet and asked about their management, we found out that all of the horses were actually turned out to a paddock for 30 minutes every day with no dung removal. So there was obviously transmission of infection going on in the paddock. So in this case, the trainer was able to reduce his anthelmintic use because he used to treat these horses very regularly, all of them all the time. He was able to reduce his anthelmintic use by only treating those horses below a certain threshold. But more importantly, he was able to understand that actually there was a risk factor for infection through the paddock turnout approach, and was recommended to remove dung from that paddock so that the horses weren't getting continually infected. So how do we bring all this together? So I've discussed risk assessment. I have discussed management measures to reduce transmission of the parasites from paddocks, and I've discussed the different tests. So how do we bring all this together to have a sort of calendar-based program? And I show an example of how you can do this here. So first of all, it's important to assess risk, as I've mentioned many times tonight, and that will help inform what management to apply, what improvements to advise, but also as well what tests to apply and how frequently to test them. Then you apply your management and diagnostic-led approach. So it's important to provide advice on excellent paddock management in terms of paddock hygiene, stocking density, quarantine measures, for example, and then to consider what test to use. And as I mentioned, fecal egg counts are the cornerstone of all, should be the cornerstone of all worm control programs. And we should consider applying these tests, particularly if horses graze outside in the winter, starting in February, and then continue those tests at 8 to 12 week intervals thereafter. And then coming into the spring, as I mentioned, to apply the tapeworm test to identify any horses that might be releasing tapeworm eggs onto the paddocks at the time when the arabited mite populations are increasing, and then treat those horses that test positive in the test. And then in summer, combined with the midsummer fecal egg count test, to consider an efficacy test, so taking a second sample at 2 weeks post-treatment to understand whether or not those anthelmintics are being used or being effective. A further egg count test, and then going into the autumn, consider a tapeworm test to assess horses in terms of the level of burden they may have accumulated over the grazing season, and to identify those horses that might need treatment to reduce their burden, to reduce the risk of colic. And in those low risk populations, either consider not treating for small redworm larvae, or to consider in those low risk situations to use the test to inform the decision of whether or not those horses require treatment. So thank you so much for listening tonight. I hope everything was clear to everyone. I will check the questions in the Q&A section on the Zoom. And all it remains for me is to thank all the people that were involved with the research that I discussed tonight and the funders who provided the support for the research projects that were described. And thanks very much to the two Katies and Dengie for hosting this tonight. Thank you.
Oh, brilliant. Thank you so much, Jacqui. That was fantastic. Really, really informative. We've had a couple of questions come through. So it's all right if we just do those now, and then I'll move on to my part of the presentation. So firstly, one question is, how reliable is the small redworm blood test?
So the small redworm blood test is very reliable because it takes quite a simple measure. It measures a level of antibody to the worm antigen. So in terms of reliability from day to day and between the plate, it's very reliable. What we do is include on each plate a calibration curve. So that is like an intra-assay control where we measure total IgG, and then every horse is measured, its result is measured against that. In terms of its reliability, it has a very high sensitivity, particularly the 1,000 worm burden. It's something like 97.8% sensitive, with a specificity above 80%. Now, it's important to remember in terms of the specificity, where you might get false positives is where people are testing too close to treatment and the antibodies levels that were directed to the worms present at the time of treatment hadn't had a time to come down. So it's really important that you leave enough time between the last treatment before testing, and we would recommend that that's at least 4 months. If anyone on the webinar is interested in knowing a lot more about the small redworm test, how we validated it, how we developed it, some guidelines around its use and interpretation in practice, just go on to our website, austindavis.co.uk, and there's a whole section about the test, its development and its interpretation.
Oh, brilliant. Thank you. We'll try and pop the link to that perhaps on the email that we send out to everybody tomorrow as well. So you've got that. And then another quick question is small redworm the same as what is referred to as encysted redworm?
Yeah, sorry, I perhaps should have shown a life cycle at the start of we're on part 2 of the thing. So small redworm is the name of a group of nematodes called cyathistomins. That's a big group. There's actually about 50 different species in there, but most horses are infected with 5 to 10 common species, with 3 particularly common species, which are the ones represented in the small redworm test. So the small redworm is eaten from the paddock, okay, and it goes into the horse, enters the intestine, and then the larvae that are eaten from paddock go into the gut wall. And within that gut wall are the encysted larval stages, encysted larvae, or encysted small redworm larvae, and they can exist as in the intestinal wall as early L3, which are tiny, late L3, which are a bit bigger, and then they molt to a developing L4, and all of those stages encompass encysted larvae. And once the L4 are ready, they then emerge back out of the gut wall into the lumen to molt to L5 and then become adults. And that's a really critical part of the life cycle, the encysted stage of small red worm, because they can build up to huge burdens, mucosal burdens of hundreds, thousands of millions of worms, particularly in young horses on poorly managed paddocks. And when they emerge, they can cause that nasty disease known as larval cyatostominosis. So yes, the simple answer is yes, encysted larva is part of the small red worm life cycle.
Oh, brilliant. Thank you. That's great. So we have had a few more questions on the Q&A, but Jacqui, if it's okay if I could leave you to answer those ones, please. We've had a few in the chat box as well. And then I'll move on to my part of the presentation for this evening, and then we should have some time at the end as well, just to go through any additional questions. Fab, thanks, Jacqui. So I'll just share my screen now. Bear with me. There we go. So that should be on everybody's screens now. Last week we talked about some of the key reasons why fibre is so important for the horse's digestive health, and really why we should be prioritising fibre in our horses' rations. I think that's often the main thing that we think about when we kind of thinking why we need fibre, so for both horses and for us as humans as well. But today I wanted to spend a bit more time talking about some of the, I suppose, lesser known or less frequently talked about benefits of fibre for the horse, which also really makes sense when we think of how the horse has evolved and how they're functioning as a herbivore as well. But firstly, as this is, of course, a digestive health webinar, so I wanted to start off just by recapping quickly and getting everybody up to speed on some of the key reasons that we spoke about last week as to why fibre is so important for gut health. So firstly, the nature of the chopped and long-stemmed fibrous materials means that it's going to require more intense chewing pressure, a greater number of chews in the horse's mouth compared to mixes or cubes. And what this does is results in a greater production of saliva for the horse, which is not only important for lubricating the food as it kind of passes through the digestive tract, but saliva also contains bicarbonates, which help to buffer acidity further down into the horse's stomach. And secondly, when it comes to gastric health, as well as the additional buffering which can come from the saliva, our high fibre materials like our forages can also create a really nice fibrous mat, which basically acts as a physical barrier to acidity in the stomach. So this is one of the reasons why it's recommended to feed a double handful or perhaps a sub-scoop of a chopped fibre 20 or 30 minutes or so before exercise to help line the stomach and reduce that acid splash. Fibre is also really important for encouraging gut motility. So just like in humans, the horse needs plenty of fibre to keep everything moving through the digestive tract and to promote regular bowel movements as well. Too little fibre in the horse's diet can result in a buildup of gas, which can potentially lead to colic-like symptoms. And then for the hindgut, fibre can play a really big role in maintaining the health of the microbial population, or the millions of bugs which live in the hindgut, and whose job it is to ferment the fibre for the horse to utilise. This fermentation process produces these short-chain fatty acids, which will have different purposes. So, for example, a high-fibre diet will generally produce much greater levels of butyrate and acetate compared to a high-starch diet. And since butyrate in particular is a really important energy source for the cells which line the intestine, which are called colonocytes, it's really important to make sure we have a sufficient production of this from our fibre fermentation, because this is so key for maintaining the function of the intestinal barrier and supporting our horse's gut health. And this is an area we'll come back to in a little bit more detail later on. And in addition to these points here, as the starch increases, fibre intake for the horse generally tends to reduce, and high starch diets we know can increase the risk of problems like colic, laminitis and gastric ulcers, just to name a few. And starch overspill into the horse's hindgut can also potentially result in this disruption or dysbiosis to the microbial population, which live there as well. But as I mentioned, fiber's got lots of other benefits for the horse. So we'll spend the next part of tonight's session just looking at some of these in a little bit more detail. So I thought a really good place to start would be to look at the horse's energy intake. And although I've got an image on the screen of some horses clearly in a higher level of work, energy is something which is applicable really across the board for all horses. And something which is often forgotten is that energy and calories are essentially the same thing. So calories is just literally a measurement of energy. So if we're talking about putting in more calories for weight gain, we are in fact talking about putting in more energy to the horse, and vice versa. If we want more energy for exercise, that basically means we're putting in more calories. And in the context of human nutrition, we'd usually use calories or megacalories to measure the energy content of a food. But when it comes to the horse, generally in this country, we would measure energy from their feed in megajoules of digestible energy. So you might see it as it's written on the screen, mj per kilogram. So for example, an average hay in the UK will typically supply around 7 to 9 megajoules per kilogram of digestible energy. And energy in the horse's diet can be obtained through a few different sources, but the main ones that we tend to look at are carbohydrates, which include our fibre, starch and sugar as part of this bracket, and also the fat content as well. So the most straightforward way to assess if your horse is having enough energy in their diet is through body condition scoring or fat scoring, which many of you may well be familiar with already. And at Dengie, we use the 0 to 5 scale, which is shown there on the screen, where a score of 0 out of 5 would indicate a horse is in very sort of poor, emaciated condition. And then a score of 5 at the other end of the scale would represent a horse who is obese. But the 1 to 9 scale is commonly used as well. So whichever one you use, it's absolutely fine. It works on very similar sort of principles. The most important thing is to keep consistent with whichever scoring system you're using. Now, because we know energy and calories are the same thing, in very basic terms, a horse who is overweight is very likely to be receiving certainly sufficient or actually excessive levels of energy from their diet, whereas a horse in poor condition is probably not receiving enough energy in their diet. Now, of course, there are other factors to consider. So, for example, if the horse is in poor health, then this can affect how they are utilising the energy that they're consuming. But fat scoring is a really nice place to start when assessing a horse's energy intake. And when it comes to thinking about energy, I think a lot of people's minds often jump straight into looking at the sugar content of the feed or the forage. That's certainly something we sort of think about in the context of human nutrition, is the sugar level. Now, all forages like hay or grass will contain some sugar, and this is going to be providing the horse with some energy. So, for example, if we've got around 10 kilograms of hay, on average, this may provide about 1 kilogram of simple sugar, and this will supply around about 16 megajoules of energy. I should point out this won't include the storage sugars, which so this probably will be quite a bit higher, but basically the sugar will be contributing somewhat towards the horse's energy needs. However, the key thing to remember is that the horse will also be getting energy from their fibre, which sort of fits in with the whole purpose of the horse being a herbivore. So the microbial population, or the bugs in their hind gut, can break down the fibre to release the energy, and the horse then utilises that energy. So actually 10 kilograms of hay overall will probably provide closer to 80 to 100 megajoules of energy, all in all for the horse, and it's not just about the sugar. And this will, of course, vary a little bit throughout the year, especially when we're talking about grass and sort of environmental factors, which can affect the energy that different forages will provide. But it just goes to show we do have those different forms of energy in our forages, and there is still some sugar in there. And then the graph on the right of the screen just shows in yellow the amount of energy which will be supplied on average each day by 12.5 kilograms of hay. And then the bars in green are the amount of energy that the horse needs. So a 500 kilogram horse at different levels of work. So you can see that for sort of maintenance and light levels of work, the hay is quite comfortably providing enough energy to sort of meet their requirements there. We're well above the sort of minimum intake that they need. There are, of course, other factors like age, environmental conditions, and breeding status, which might influence how much energy a horse needs. But it's a really nice baseline just to look at. Now, as a horse's workload increases, their energy needs do become greater, and we can see sort of we might need to potentially provide additional energy sources here to help meet their requirements alongside their forage. But I think it's quite nice to see actually that even for horses in moderate or harder levels of work, there's really only quite a small discrepancy or top up from what is being supplied by the forage. So it just demonstrates that forage really does make quite a significant contribution to the horse's needs. I think it's also quite easy to see how for horses in rest, how they can still sometimes gain weight quite easily, even if they're just fed on hay only and not a lot of bucket feed, because we can see straight away that the hay energy intake will generally be exceeding their requirements. But as I mentioned, the energy levels provided by forages will vary. So it's primarily going to be dependent on the digestibility of the forage, which is basically how easy it is for the horse to extract the energy and the nutrients from that forage type. So the digestibility of the forage can be affected by factors such as the source of the forage and also how mature the plant is when it's harvested. So if we think back to our school biology days, we know that the cell walls of the plant include structural carbohydrates, so things like our cellulose and hemicellulose, but also our lignin. And it's these which give plants their structure to basically hold them upright. Now, as the plant gets taller, it will need more structure to hold it up. And so these levels of structural carbohydrates will be increased as the plant gets older. And these are less digestible for the horse, which basically means it's harder for the horse to break them down and extract as much energy from these older or more mature plants. In contrast, plants at a younger botanical age, which are less mature, will have lower levels of these structural carbohydrates, and so will be easier for the horse to break down and to digest. So in practical terms, if we think about our forages for the horse, our softer, leafier, early cut forages will typically be much more digestible and will be easier for the horse to extract the energy or calories from them. Our later cut, coarser, stalky type forages will probably have been more mature when they were harvested, and so these will likely have less energy available to the horse. So if we've got an underweight horse, we need to be thinking about not just the amount of forage that we supply, but also the maturity or the quality of that forage as well, thinking about what does it look like, what does it feel like. Now, this will just give us an indication. It's not an exact science there. The only way of knowing for sure is to do a forage analysis, but it's a good starting point if that's not a service which is an option for you. For example, if you only have sort of small, changing batches of hays regularly. And then when it comes to the fibre in our horse's bucket feed, we've really got quite a wide range of high fibre materials which are available to us to use. As I mentioned, generally anything which is cut later will typically be less easily digestible and have a lower energy level available to the horse. Now, in contrast to this, ingredients, things like sugar beet pulp, are very, very easily digestible for the horse. This is because for sugar beet pulp as a fibre source, it actually doesn't need much structure to it. It grows underground, so it doesn't need that indigestible fibre content to help it stand upright, tall above the ground, like some other fibre types would. So that's one reason why sugar beet pulp is so really lovely and easily digestible for the horse. And also we're sort of working backwards along our little list up here. We've got alfalfa, which in this country is typically cut earlier in the season. So again, the plant is a little bit younger and it's potentially more easily digestible for the horse. So these lovely, easily digestible fibre sources like our beet pulp and our alfalfa, they can make a really significant contribution to the energy or the calorie requirements of either performance horses or for horses who just need that little bit of extra support in maintaining their weight and condition. These are still high fibre materials, so they're great for the horse's health and for sort of digestive health and well-being. And if we still need more energy, then using feeds like alfalfa with added oil can be a really great option just to increase that energy content even further. It's important to note here that these sort of fibre sources that we're talking about, although they've got a higher energy content, they're still typically very low sugar and low starch. So they will be primarily providing that slow release energy rather than quick release kind of whizzy energy that might be supplied by higher starch materials, things like cereals like oats or barley. So whilst sort of on paper, we know our highly digestible fibre sources like our alfalfa and our sugar beet pulp can provide, sort of as much energy as cereal-based feeds. Do they really work in practice? Do they really actually help? Are they sufficient to sort of fuel performance and support horses working at higher levels? Traditionally, I would say competition riders or racehorse trainers have maybe been a bit more concerned about using high fibre diets. They sort of have the worry that they might increase gut fill, reduce performance. They worried they won't provide enough sugar or glucose to help the horse refuel, or simply that the horses just won't eat enough to meet their energy requirements. But since we know that high fibre diets are certainly preferable for the horse when it comes to supporting gut health in comparison to our more traditional high starch cereal-based feeds, there's been more recent research lately which has focused on kind of answering this question and actually can fibre help to fuel performance. And the key element here that a lot of the researchers have been interested in looking at is acetate. Acetate is one of the key short-chain fatty acids, which is produced during fibre fermentation in the horse's hindgut. And as I mentioned, it's produced in higher levels in high fibre diets compared to in high starch diets. Now, acetate has also been confirmed as an important energy source for the horse when they're exercising. So I don't know if there's anybody here tonight who perhaps might have done A-level biology. You might remember the Krebs cycle, or otherwise known as citric acid cycle. Well, acetate is involved in this process to kind of help produce energy for the body. So there was a relatively recent study which was done in 2023 by a research group in France, and they looked at a group of French trotters in training, so doing sort of relatively hard level of work, and they fed two different diets. So they had a control diet was comprised of hay and oats, and then the second diet was a combination of hay, a much smaller proportion of oats, and a larger amount of alfalfa, which was a mixture of chopped and pelleted alfalfa. And the results of this study showed a couple of really interesting findings. Firstly, they found that all horses actually lost weight to start with, which was possibly due to kind of an increase in training intensity over the trial. But they then maintained a consistent weight throughout the trial. There was no difference between the two diets. So that's a useful finding in itself because it backs up what we know, that you don't necessarily need a high level of cereals in the ration, and kind of good quality digestible fibres can be just as good at sort of maintaining condition compared to a cereal-based diet. And then the second point that they found was that there was no effect of the diet on the various performance parameters that they measured, so things like speed, heart rate, oxygen consumption, and acceleration. So this means that both diets were actually very, very similar in this regard. The higher oats diet didn't do any better than the high alfalfa diet. So sort of showing there's no actual extra benefit of feeding oats for performance. So if there's no extra benefit of oats, do we actually need them? Is the sort of next question really that leads on from that. Now, of course, there were still some oats fed within the alfalfa diets. I think there's definitely more research to be done in this area. But actually, even reducing the amount of starch fed and increasing the good quality digestible fibre for horses in harder workloads is still going to be a step in the right direction. We know it's not going to reduce performance, and it's certainly going to be beneficial in supporting both their health and their welfare as well. So we know that fibre from forage and other high fibre materials can make a really valuable energy contribution to the horse's ration, but actually what else does it supply in terms of its nutrient levels? So when we talk about a balanced diet for the horse, although this can kind of refer to a whole range of different factors, primarily what we're talking about when we sort of talk about a balanced diet is the levels of vitamins and minerals that are being supplied. And these are required by the horse, just like in the human, to be able to provide their sort of perform their normal bodily functions. Any excesses or deficiencies of nutrients, vitamins and minerals can potentially impact on their health, but also on their performances as well. Certain things like age, body weight, level of work, whether the horse is used for breeding, these can all influence an individual's specific requirements. So for example, horses in higher levels of work will typically have higher requirements for certain nutrients like antioxidants, vitamin E and selenium, for example. What I think is quite important to remember with vitamins and minerals, though, is that more is not always necessarily better. So it's really about the balance of the nutrients within the diet as a whole. Minerals can actually interact with one another, as is shown in the sort of mineral wheel on the right of the screen. This really means that an excess level of one mineral may result in a deficiency of something else. So we really need to consider minerals in sort of ratio in relation to one another, rather than just supplementing with individual nutrients. But what does forage actually provide? So I think it sounds quite easy sometimes to think, well, we know what the ratios are, let's just have a look at what's in our bucket feed. Is it meeting requirements? But actually it's so important to consider the contribution of the forage. This is going to supply nutrients as well, and also should be making up kind of the majority of the horse's ration. So things like green leafy plants like fresh pasture or alfalfa would typically contain good levels of natural antioxidants, so things like vitamin E, beta carotene, which is kind of basically a precursor for vitamin A. These levels may be reduced in conserved forages like hay or haylage, but if we're precision drying our forages or alfalfa, for example, using high temperatures, this acts to kind of lock in those natural nutrients and helps to retain those good levels within the plant, which can then be passed on to the horse. Forage is naturally also very high in potassium, so generally for horses with access to plenty of forage, their potassium requirements should sort of mostly be being met, and this is why potassium is not usually added to in sort of high levels in compound feeds. We generally don't need a lot extra if they have got plenty of forage. And grasses and legumes like alfalfa also tend to provide good levels of other minerals, so things like calcium as well. It is worth noting, though, that even very good quality forages in this country, good quality hay, haylage, or even pasture will still be lacking in certain nutrients. So it is advised to utilise a balancer or a vitamin and mineral supplement to help top up the nutrients that are provided in your horse's forage ration and just help make sure they are getting everything they need. So now moving on to some other benefits or sort of effects of a high fibre diet for the horse. And firstly, starting off with behaviour, which is something that we definitely get asked a lot about, I would say, on the feed line here at Dengie. There's been a number of studies which have shown a link between diet and behaviour in the horse, but also in other species as well. And one study in horses was one which actually Dengie were involved with in 2015 in conjunction with a researcher at the University of Edinburgh. And in this study, they compared two different diets which provided the same overall level of energy. The key difference between the two diets was the level of starch that was supplied. So one diet was a cereal-based mix, which had a starch level of 22%, which is pretty normal, fairly typical for a sort of medium energy mix-based feed. And then the second diet was an alfalfa feed, which had a starch level of just 2%. And the horses were fed each of the two diets in a crossover study. And the results of the study found that when the horses were fed the cereal-based diet, they were really much more overall reactive and less consistent in their behaviour compared to horses who were fed on the high fibre diet. So although high starch diets are generally considered a good option for humans in higher levels of exercise. They're perhaps not necessarily the ideal choice for providing energy for working horses, and actually instead feeding a really good quality fibre diet to supply the energy we know is beneficial for gut health, but can also help to potentially reduce the horse's reactivity and potentially make the horse a little bit easier to handle as well if you are dealing with a fizzy or more excitable horse or pony. So next up, we've got dental health. So we touched on this earlier and also a bit more detail last week about the importance of forage for saliva production, with forages requiring kind of more chewing compared to mixes and cubes. But something else which is quite interesting to note here is that the actual motion that the horse chews will also differ between different types of feeds. So there was a study which was done back in 2007, which found that higher fibre diets encouraged slower and longer jaw movements compared to feeding high levels of mixes or cubes. And they found that these slower and longer jaw movements actually allowed for more even wear on the teeth. In comparison, feeding high levels of mixes and cubes actually increase the risk of dental problems, so things like sharp edges or enamel overgrowths, and these could potentially create further problems for the horse and possible discomfort down the line, potentially requiring sort of more dental intervention as well. So it's another reason why sort of feeding that fibre is so relevant for the horse's dental health and keeping that first stage of the digestive system working really nicely. And actually more recently, there was another study which looked specifically at the effect of different feeds on the level of acidity within the horse's mouth. So they looked at a few different types of feed and forage, and they actually found that a soaked unmolasses sugar beet pulp was the only feed which reduced the pH in the mouth immediately after feeding, so it became more acidic in the mouth. Now, the levels did actually return to baseline pretty quickly within about 15 minutes. So it's not really a particular cause for concern. We're still absolutely sort of recommending sugar beet pulp. It's still a great feed. But interestingly, the authors did actually suggest that this could have been because the sugar beet pulp doesn't require as much chewing. So we've got less saliva being produced, and we know that saliva is really important for buffering acidity. So I think there were some limitations to this study, but it's just another interesting aspect to consider, really, when we think about why promoting some chew time is still beneficial when it comes to dental health, and just another reason really why adding a chopped fibre into the bucket can be so useful for the horse. So next, moving on to hydration. So as well as ensuring your horse is consuming plenty of water and adding electrolytes for horses who are perhaps sweating or traveling a lot, a high fibre diet can also play a really big role in supporting hydration for the horse. And the reason for this is because fibre basically acts as a reservoir for water in the hindgut. And this provides reserves that the horse can draw on when they need to. So, for example, when they've been sweating. And it's quite common, I would say, for horses to perhaps back off their forage when they're travelling or staying away from home. So if you are worried that your horse is perhaps not eating as much forage when they're away from home, it can be a good option to maybe look at choosing a really palatable or really tasty chopped fibre, which can be fed in a bucket as a bit of a partial forage replacer. Making sure, of course, that these are introduced nice and gradually in advance of travelling, just so that we're not making any sudden changes that can upset the gut. But it's just a really nice alternative option if your horse is not a big forage eater when they're away. You can still make sure they're getting plenty of fibre for all the reasons that we've spoken about, but also to help with that hydration as well, which is particularly relevant for the competition horse. And something else just to be aware of in this area as well is that different feeds and different fibres will have different kind of capacities for holding water and different amounts that they can carry. Sugar beet is a great example here. So of course, sugar beet, as we know, is fed soaked, so it is going to introduce water into the digestive system anyway. But because sugar beet is also a very digestible source of fibre, it breaks down nice and easily and releases that water to help aid hydration for the horse. And one of the things that makes sugar beet pulp so easily digestible is because it contains a really nice high level of pectin. And another ingredient which contains a lot of pectin is alfalfa. So if we're looking at kind of combining these two ingredients together, they can be great choices for the competition or the performance horse. So now moving on to something which I'd like to say is perhaps slightly less relevant for the time of year, as the weather is slightly starting to warm up now in some parts of the country. But I think definitely keeping warm is still something to bear in mind for those chillier days, or indeed actually looking ahead to next winter. And fibre really does play quite a key role in helping to keep the horse warm and helping them to maintain their temperature. As we mentioned earlier and last week as well, fibre is digested in the horse's body through fermentation by the bugs and microbial population in the hind gut. And while they're doing this fermentation process, they're basically producing heat as well. So this is one of the adaptations that the horse has to help them keep warm and maintain their body temperature. It's basically like their own central heating system and really helps to keep them warm from the inside. And now, of course, there are a whole range of factors that can influence how a horse might maintain their temperature, but ensuring a horse has access to plenty of forage and fibre is definitely a really good key aspect to think about for supporting your horse over the colder months. And so now coming on to the benefits of fibre for hoof health, which I think is possibly something that maybe people wouldn't think of straight away when we think of why fibre is good for the horse. I think a lot of you will probably be familiar with, or perhaps at least have heard of biotin, which is a water-soluble B vitamin. And this is commonly recognised as being beneficial for horses with poor hooves. And just like other B vitamins, biotin is actually produced by the microorganisms in the horse's hindgut as they are fermenting the fibre. So as well as producing heat as part of this process, they're also producing B vitamins as they're working hard fermenting the fibre as well. So when plenty of fibre is being fed, we've got this then really nice healthy population of microorganisms, and these can usually produce sufficient B vitamins, including biotin, to meet the basic requirements of most horses and ponies. So of course, there's lots of different factors which can result in poor quality hooves, but one reason could potentially be that we've maybe got a slightly less healthy digestive system, which maybe could occur if we've not got enough fibre going through, or if there's another reason why perhaps the environment in the gut maybe is slightly less conducive to allow the bacteria to function efficiently. So of course there's lots of management factors and other things that do play a role, but I think it's really important to be aware that fibre intake can be a part of that puzzle when it comes to hoof health, and it might just be something else to consider if you are dealing with a horse with poor hoof quality, as it can be potentially quite an easy or relatively straightforward option to sort of implement. I would say this is something we perhaps do tend to see more of in performance horses and sometimes in maybe good doers. So it is really important just to maximise fibre intake for these horses and sort of look at choosing the most appropriate type of forage for them. So just very quickly, I mean, we did touch on this briefly last week, but using things like lower energy fibre sources like straw as part of the forage ration, or maybe choosing a later cut, less easily digestible forage can be really useful choices for good doers or for overweight horses to help make sure they're getting the fibre that they need to support gut health and therefore to support biotin production whilst avoiding too many calories. And so next we're going to look at the horse's immune function, and we're actually going back to the villi, which are these tiny little hair-like structures which line the intestine. And we spoke quite a bit actually about this last week, but there's been lots of research in other animals and more recently in horses to indicate that feeding high starch, low fibre diets can result in the villi starting to basically erode and kind of shrink in size. And these are the primary site of nutrient absorption in the horse's gut, and they basically increase the surface area available to maximize that absorption capacity. So if they're reducing in size, we're ultimately going to end up with less efficient nutrient absorption in our horses, which is of course not ideal. But the other aspect to consider here when it comes to the horse's immune function is that about 70 to 80% of the horse's immune cells are located within the gut. And so a reduction in the size of the villi may also compromise the horse's immune function as well. So this is another reason why we really want to be keeping our starch levels as low as possible to help maintain gut health and support their immune function. And the other element that we can look at when it comes to immune health and sort of its links with digestive health is the actual integrity of the horse's colon. So if we've got a really nice healthy gut, we've got a lovely strong intact intestinal barrier, intestinal lining, and this is lined with mucus, which basically helps to protect the cells which line the gut, our colonocytes. And this mucus is continuously being replenished while it's being utilized by bacteria as an energy source as well. So it's pretty natural that horses will inevitably consume some harmful pathogens at some point. But in normal circumstances, these will stay in the gut. They'll just pass through without causing any problems at all, and the horse will be completely fine. But if we've got the situation where we've got a lower fibre diet, the mucus layer can start to become eroded. And this is one kind of really line of defense that the gut has against pathogens that might enter the system. And if this mucus layer starts to become eroded and we've got this low fibre diet, it can also start to compromise the health of the cells in the sort of gut lining tissue itself. And then the gaps between these cells start to become bigger, and then this results in the gut potentially becoming more permeable or leaky. And then substances which really shouldn't be escaping from the gut do start to cross that intestinal barrier and can enter into the bloodstream and then into the body, which can then result in ultimately kind of poor health and potentially disease as well. And really the reason it's going wrong here is that there's too little fibre. So it's definitely something to really sort of another thing to be aware of as well. And this is something which I suggest is kind of particularly relevant for the performance horse or the racehorse. These individuals will typically be exposed to more pathogens as they are travelling. They're competing in lots of different locations, getting out to train as well, perhaps. And yet traditionally these types of horses perhaps may not be fed as much forage as they perhaps need. So it's definitely something to consider when we're managing these types of horses, just to really help optimize their health and their performance as well. And finally, we're going to talk just a little bit about the horse's lymphatic system. I think the lymphatic system is possibly an area that we perhaps don't fully know everything about just yet, and yet it is really important to the horse's health and performance. And it basically consists of this big kind of network of vessels and these lymph nodes, which help to maintain the fluid balance and the health of the cells within the horse's body. And just like other systems in the body, the lymphatic system does actually interact with other systems. So, for example, the immune system. So as waste material from the body kind of passes through these lymph nodes, it's basically analysed for these potential pathogens or harmful material. And if these are present, then it can trigger an immune response. So the lymphatic system is a little bit different to other systems in the body, so like the circulatory system, for example, which has got the heart to pump blood around the body and keep the blood moving. Instead, the lymphatic system really works by using pressure. So as lymph sort of builds up in these little vessels, it keeps filling up until the pressure is so high that it can push the valve open and keep the lymph moving through as it should. And this pressure is sort of also stimulated by other factors, say things like muscle contraction, so movement, and also the movement of the gut as well, which is we call peristalsis. So in doing these things, the horse is basically helping to essentially detox its own body and keep the flow of lymph moving as it should. The horse has about 8,000 lymph nodes, which is quite a lot when we compare it to only around 600 in humans. And these lymph nodes basically slow the movement of lymph. Half of the horse's lymph nodes are actually located within their colon. And so these ones really function best when there's lots of peristalsis, lots of gut movement occurring. So basically when there's lots of food trickling through the gut, as it should, we've got more peristalsis and better sort of function of the lymph nodes. Physical movement, so literally the horse moving around, is also really beneficial to stimulate the flow of lymph. So that's why horses who maybe are standing still for long periods can end up with filled legs. So for example, a horse on box rest that's perhaps not eating as very much, they can potentially experience lymph accumulation, which might be evident as those filled legs or perhaps even swelling around the sheath or the udder. So to keep up the movement of lymph is why sort of one reason why a cool down after exercise is usually recommended. It helps the horse to kind of clear out those waste products. But also another reason why we're encouraging people to try and feed more fibre and avoiding those long periods without anything to eat. So I think that brings us to a close, and I think the real take-home message here is to remember that fibre is not just important for the horse's gut health, but also has lots of other benefits for the body and for the horse's overall health and welfare, really. So whether that's for the old retired pony or for the top-level competition horse, and actually why a high fibre diet is so important and really should be the aim for all horses. For those individuals who are very good doers, who I know sometimes people are worried about feeding them sort of too much, there are sensible measures that we can look at to help lower the energy or the calorie provision from their forage while still making sure they've got the fibre that they need. If this is something you would like more information or advice on, if you have got a horse or pony in this situation, please do get in touch with our feed line. We'd be very happy to help and give you some advice there. So that leads us nicely on sort of where you can get further information. So I've just popped the feed line's contact details on the screen there. We've also got lots of webinar recordings on our YouTube channel, and last week's webinar is available on there now as well. So do go and catch up with that one in case you missed it last week. So just before we sort of wrap up and see if we've got a bit of time for a quick Q&A, just wanted to run through quickly anybody who is looking to get their CPD points from this evening. You do need to complete some quiz questions to be eligible for your points. And I think Katie will hopefully be able to pop those links in the chat box for you in a moment. The quiz questions for this week's webinar will be live until next Wednesday, the 9th of April. So you've got until the end of the day next Wednesday to complete these. If you are an SQP with AMTRA, we will log your attendance and your points with AMTRA directly once you've completed the quiz questions. So if you don't complete the quiz questions, you won't get your points from this evening's webinar. BHS accredited professionals, once you've completed the quiz questions, just make sure you also complete your normal BHS CPD feedback form. We will send that through on a link as well. I think we'll pop that in the chat box, but we can also send it on email just in case any of you aren't familiar with this, or if this is your first CPD event. That's the form you need to fill in. And for Pony Club registered coaches and assessors, you will be sent your evidence of attendance through email once you've completed your quiz question. Just make sure you tick the box on the form that says you're registered with Pony Club so that we know to send some evidence over for you. I think you need to sort of submit that to get your approval there from the Pony Club. I did just want to say as well, everyone is very welcome to complete the quiz questions, even if you don't need CPD points, you're very welcome to complete them just for your own sort of records as well. And there is an option to go back and see how many you got right. So hopefully that will be useful for everybody. So I'm going to stop sharing my slides now, and we'll just have a quick look and see if anybody has any questions. Jacqui, have you been? I don't know if there's been many that have come through on the chat tonight.
Very dark in Scotland. Yeah, I have answered most of them. Just the one that I left actually for just live really saved me typing. Someone asked about the threshold for treatment of EPG based on fecal egg counts, and it has been described at different levels. There's actually very little research. There's one study done, I think, a couple of years ago by Americans that showed a threshold of 200 EPG reduced treatments by about 75% in sort of typical equine populations. So the guidelines say you can choose a threshold between 2 and 500. 200 I would take as the bog standard one to apply in most populations. But if you find, particularly in low risk groups where, so if you are analysing egg counts and advising treatment, if you've got a low risk group and there's very few horses are positive and they're well managed, you can actually just increase the threshold up to 500 eggs per gram and just treat the odd horse. It's important to integrate what you know about the group's management as well as the test results. So if dung's been removed as well, again, a higher threshold can be applied. In fact, in the donkey sanctuary, where I provided advice in the past and they had real issues around resistance, we actually increased the threshold for treatment to 1,000 eggs per gram to really drive down the amount of treatments we're applying, but at the same time improving the management through dung removal. So it is a bit of a sliding scale. 200 is a kind of bog standard, but 500 can be used as well in certain situations. I hope that answers the question.
Oh, lovely. Thank you, Jacqui. That's great. We did also have a couple of other questions which came through just in advance of the webinar. So I'll just whiz through a couple of those now, if that's okay. So one of them, this is sort of slightly specific advice for their own horse, but I think it's a general point which may be applicable to a few different people. So this lady says, my horse has lost weight and my vet recommended worming with Panicure to see if that helps. I don't normally use wormers as my horse's fecal egg counts are all okay. What should I do? Any sort of suggestions there or any comments that you'd like to share, Jacqui?
Well, I think so it's probably important to go through a differential diagnosis of what's causing the weight loss. So that's the first thing. So it could be a parasitic cause, but it could be other reasons, dental reasons, diet, other pathologies, other types of disease. So a lot would depend on the clinical background of that horse and a differential diagnosis. And part of that would be a parasitology workup. So although the egg counts might be low, a small red worm, score really high off scale might be indicating that there might be a higher burden of small red worm there. To the exclusion of all other parameters, I'm looking at other features of blood, for example, low albumin, hyperglobulinemia, which is sometimes indicative of a parasitic problem, and the history. If the horse has been exposed to many worms, then perhaps consider a larvicidal treatment. Probably in this day and age, unless efficacy of fenbendazole has been proven, then I would usually select moxidectin as a larvicidal treatment for small red worm. Particularly in horses, perhaps that are presenting with weight loss, keeping in mind it's quite a toxic drug, so be very careful with the dose if it's a horse that's lost a lot of weight. In terms of Panicure, obviously it's only a 5-day course that's licensed for use against all the different insisted small red worm stages, so that would be a 5-day course and not a one-off treatment if efficacy was assured against small red worm with fenbendazole.
So absolutely, so sort of getting making sure you've ruled off everything else and done all your testing and things before you go straight to a worming treatment.
Yeah, absolutely. Especially one that might not work.
Yes, absolutely. Fab. Brilliant. Thank you. And another sort of question, I suppose, is do you have any advice for people who are perhaps more limited on their yards in terms of what they're able to implement in the sustainable worming practices? So what would be your kind of suggestions? I know there's a lot of cases where livery yards may have restrictions and people are kind of limited in what they can do.
Yeah, and that's why no one size fits all, and it's important to do a yard specific a group horse specific risk assessment in all cases and base the advice going forward. There's always an aim just to reduce transmission via the environment. So and not be complacent and just say, oh, well, there's too much to do. I'm not going to do anything. I'm just going to apply treatments. There's always things that people can do. And what's your worm risk, for example, gives the optionality. So okay, so one thing you might not be able to do is reduce stocking density because you've got lots of horses on a limited paddock. So in that case, it's even more important to do dung removal fairly regularly and try and encourage. And then in a DIY livery yard, not everyone's doing it. So just try and provide incentives for people to do or create some sort of rule list if you're the manager. And then in those situations as well, I kind of touched on this earlier, even if people are struggling to remove dung and they can't reduce the stocking density, well, then more frequent testing would apply then rather than just giving lots of treatments. So you might want to do egg counts a bit more frequently, every 8 weeks, and then treat those high shedders, but being very aware of the level of anthelmintics you're using, which products you're using, whether or not they're working, and considering not using the same types of anthelmintics, keeping in mind that moxidectin and ivermectin are the same class, so are likely to have a cross-selective effect because their target proteins or molecules in the worm are similar. But there's always something that can be done. And that's where we give advice people, let's just break it down into bite-sized chunks and what are the achievable things and then continue to monitor. And that's the usefulness of monitoring, because then hopefully if your management changes are successful, the test results will improve, and that will then incentivize people to do further improvements to try and drive down the number of positives in their population.
Brilliant. Thank you. That's fantastic. Just one more very quick question, which I hope is sort of probably be quite a sort of straightforward answer, but about the tapeworm saliva test and the sort of timings of when you would do this. So do you need to be careful, for example, if the horse has eaten recently? So we spoke obviously in my presentation about saliva production, and are there any restrictions or recommendations with when you actually do the test?
Sure, absolutely. So it's really important to follow the guidelines that come out with the saliva kit that you either can purchase direct from us or you can get from your prescriber or your veterinary practice. The most important thing is to that horse doesn't have any access to food or water for 30 minutes before the test. I didn't have enough time to put all the slides in tonight, and I still talked for too long. But anyway, so what we did this study, I think before the test was actually initially introduced, that actually if you feed a horse and then you sample them soon after feeding, you measure the total antibody in the saliva and it's below the detection limit of the assay. So you have to wait at least 30 minutes after the horse has finished feeding and then apply the test then. And hopefully the saliva will be sufficiently concentrated that we measure. And like the small red worm test that I mentioned earlier, we measure total antibody in a calibration curve. So there's always that intertest QC step. So that's why we report saliva scores and not optimal density that we measure at the end of the ELISA test. So it's a saliva score against a calibration curve. And obviously there's a 3-test assay that we use. And part of that assay is we also measure total antibody to assess the level of dilution in the saliva. And we do get the occasional sample. It's not common, but I will see it maybe a couple of times a week, the hundreds of samples that come through. The horse needs to be retested because there's not enough antibody, the total antibody, to measure worm-specific antibody in the saliva. And then we provide those kits back to either the client, to the retailer, or to the person that's bought it directly to retest the horse, but with strict instructions to follow the advice precisely in terms of leaving it. Likewise, don't do a horse after a dental or if it's if it's been sedated. Again, the effects of sedation can increase salivation. So again, some people think, oh, I'll take it while the horse is sedated for whatever. Probably if you're going to do that, do it immediately after it's sedated so you don't have an impact in saliva flow rate.
Fab, thank you. No, that's brilliant. So I think we will draw it to a close there. So thank you so much, Jacqui, once again. That's been brilliant. We will send out the email to everybody in the morning with sort of the links that we've spoken about tonight as well. And if anybody has any other questions, do feel free to sort of send them over via email as well. Oh, and Jacqui's, don't forget to send the barcode with your sample. Yeah,
That's something I see every day.
it.
Where's my sample result? And then they haven't put the barcode on the test, and
Oh,
then because it all goes through an automatic system, so always send your barcode.
always send the barcode. Key take home message there.
You take home and send the barcode.
Yeah.
Thanks for all the thumbs up.
Fantastic. Brilliant. Thank you so much, everyone, for coming,
Okay.
and hope to see you again soon. Take care.
Take care, everyone.